function y is equal to c to the power of x. The function f of x is equal to c to the power of x, where c is a positive real number different from 1, is called exponential function in base c. This function describes exponentially increasing and decreasing situations depending on whether the base is greater or less than 1. Okay, so if the c is greater than 1, it's increasing, and if the c is less than 1, but greater than 0, then it's decreasing. Okay, let's have a look at that on the graphing machine, if I can find it. Okay, so if we have the function, hello, thank you. I'm just recording something. All right, so if we have y is equal to 2 to the power of x, something like that. Okay, and if we graph that, okay, it just increases like this. Okay, and they're saying that if y was, let's say, less than 1, like let's say it's 1/2, something like that, is decreasing. Okay, because if you have, let's say, if you have 1/2 to the 0, that's 1, but 1/2 to the power of 1 is going to be a half, right? 1/2 to the negative 1 is going to be the reciprocal of 1/2, which is 2. Okay, so that's why it does that. All right, let's see what happens when our c is equal to 1. Okay, and remember, 1 to the power of anything is 1, so we end up getting a nice horizontal line. Okay, that's why we're saying it's not equal to 1, but it's less than 1, like say 0.1, that's less than 1. Okay, we have a nice steep decreasing function. But when y is greater than 1, like 3, we get that. Okay, the other thing they're saying is we're going to be interested in this e to the power of x, okay, which kind of looks like this. Now, e, let's go and have a look. Okay, so we get these two functions. We have the increasing function when c is greater than 1, and we get a decreasing function when c is between 0 and 1. Okay, and the most common bases for the exponential functions are the numbers 10 and e. E is an irrational number. It means it goes on and on forever without repeating. Okay, there's no pattern repeating. And it has no end, right? So, and it can't be written as a fraction, so that's why it's irrational. So it's an irrational number that occurs in phenomena related to physics, biology, calculations of probabilities. Okay, and we already looked at y is equal to e to the power of x. Okay, but what is e? All right, so let's have a graph. And what we're doing is I'm going to look at money over time. Okay, so let's say you have a dollar, right? And that dollar is going to, let's say you invested it in something where that dollar grows at 100% annually. Okay, so at the end of the year, you still have your original dollar, but you get another dollar. Okay, so and then after 2 years, you still have your dollar, and your dollar that you had at the end of the 1 year doubles, so you get a new green one, and this green one is going to remain. So here's our green one, but that green one is going to grow a whole other dollar, okay, the red one. And then that's going to happen again. So this is going to be the same blue one. It's going to produce a new green one, like that. Okay, this green one is going to remain, okay, but it's also going to produce a new one, Okay, so when the green produced a new one back here, it became red. So it's going to make a new red one, like that. This green one is going to be here. Okay, so that green one's still around. And it will produce a new red one as well. Okay, like that. Now this red one will still be around. Okay, but it will produce a new, I don't know, purple one, like that. Okay, so notice at time 0, we have 1. At time 1, we have 2. At time 2, we have 4. And at time 3, we have 8. Okay, and notice this is like y is equal to 2 to the power of t, right? So, or f of t is equal to 2 to the power of t. So 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. And 2 to the power of 0 is 1. All right, and we can think of this as the 2 as like 1 plus 100% increase. Okay, so it's a 1 plus 100% to the power of t. All right, so it's 1 plus whatever a return is to the power of t. So it doesn't have to be 100%. It can be whatever a return happens to be. So we get this nice little formula that seems to work. Okay, now here's the issue though, is when money doubles like this, okay, what happens is you could compound it, you could look at the money at various points in time, right? And you can compound it at those points of time. So let's say we're looking at 1 year, okay, so 12 months, and it doubles in 12 months. But if that interest is compounded every 6 months, we get a different story, okay? Because what's happening is you start off with your dollar. At the end of 6 months, you still have your dollar, right? But that dollar has produced, right? Because remember, it's doubling in 12, so it's going to produce about 50. It's going to produce 50 cents in 6 months. So we have like, so think of this as like there's 50 cents emerging from this dollar. Okay, so this $1 has produced the dollar and it's produced the 50 cents. Now at the end of the year, you still have your dollar, okay, and this 50 cents, right, you still have that 50 cents, but this dollar has produced a new 50 cents, right? So this 50 cents added to the new 50 cents that this produced gives you $1. Okay, and then this 50 cents is going to give you 25 cents. Okay, so this 50 cents is going to produce 25 cents. So in all, you have 225 at the end of the year. I'm going to stop here.